So let's go through and do an example of how you would see this. The example that we'll use is for chlorine. In chlorine, if we use the mass spectrometer, it would give us the following readout. Chlorine has two isotopes, chlorine 35 and chlorine 37. Notice that many times when we write isotopes, we don't need to include the atomic number. In this case, for chlorine, it's understood that there's going to be 17 protons and the atomic number is going to be 17. So we typically don't represent that when we write out the isotopes. So here we have our two isotopes of chlorine, and we need to figure out the relative abundance. The relative abundance of the chlorine 35 isotope is 75.33%. The data that we're going to give does not list a value for chlorine 37, and we know that the atomic mass for each of these atoms is 34.969 atomic mass units for the chlorine 35 and 36.966 atomic mass units for the chlorine 37. If we want to express the average atomic weight, that's going to be equal to the sum of the fractional abundance times the mass of the isotope. In this case, we have two isotopes, so this summation or this formula is going to include two numbers. So our average atomic weight is going to be equal to the fractional abundance of our first isotope, which we need to express as a decimal, so that's 0.7533, times the mass of that isotope, which is 34.969 AMU, plus the abundance of the second isotope times the mass of the second isotope, which happens to be 36.966 AMU. We're not given an abundance of these isotopes, but if we know that chlorine only has two isotopes, all of the abundances have to add up to 100%. So that means that the percentage of the abundance of the second isotope is going to be 100 minus 75.33%. This gives 24.47%, or as a decimal, 0.2447. When we go through and do the math, our average atomic weight is going to equal 35.45 atomic mass units. And this is the number that we're going to see on the periodic table for chlorine. And this is how, by using a mass spectrometer, that all of these atomic weights are determined for each element on the periodic table.